Good afternoon, one and all. This is again your Virat Kumar, lecturer in Electrical and Electronics Engineering from the Institute of Government Polytechnic, Vaddapalli, with the semester of 4, and the subject is AC machines with the code of 18EE403C. As usually, the main topic of three-phase transformers. So today we are going to see about tapping of transformers, that is tapping and tap changing. What is the tapping and what is the tap changing? So today's session is about this. So a small recap. In the previous class, you have learnt about necessity of cooling and cooling methods. In the last session, or in the last class, we have seen about necessity of cooling and cooling methods. I hope you have revised all those things since I have posted the video in the YouTube. You can see my videos by subscribing to my channel. And moving on to the today's topic. The main objectives of today's session is, on completion of this period, you will be able to know tappings and changing. Tappings and tap changing. And offload, that means no load tap changer, and on load tap changer. There are mainly two types of tap changings, that is during offload and during on load. Offload is nothing but no load tap changing, and on load tap changing. So sometimes it may be done on load also, and sometimes it may be done on no load also. For flexibility, it may be done on load. For continuity of supply, sometimes it may be done on load tap changer also. So what are the disadvantages and advantages of both these, and why actually the tapping and tap changings are done to a transformer? So we are going to see all those things in this period. Firstly, tappings. What is tappings actually? Consumer's terminal voltage is to be maintained within specified limits for satisfactory operation of electrical equipment. The voltage of power networks supplied by transformers can be controlled by changing the ratio of transformation K of the transformers. The tappings are connections provided at different points in the windings. By tappings are mainly done, it is consumer's terminal voltage is to be maintained within specified limits for satisfactory operation of electrical equipments. That means there will be a change in terminal voltage. In order to maintain that, we require some tappings. So consumer terminal voltage to be maintained within specified limits. Why it should be maintained? In order to satisfactory operation of electrical equipments. And the voltage of power networks supplied by transformers can be controlled by changing the ratio of transformation K of the transformers. So that voltage of power networks can be controlled by changing the ratio, that is the transformation ratio K of the transformers. And the tappings are connections provided at different points in the windings, as like studs in the DC starters of 2 point, 3 point, and 4 point. You can see the studs connected in between the resistor. In the same way, the tappings are connections provided at different points in the windings. This is a tap continuation of the tapping. The following visual shows the tap changer of transformer. That were transformer tappings. Actually, the visual is not clear over here. I'll just make the diagram for you. It's okay now. So but with the white, okay, now we can see this is the winding. With a core, and this is a secondary winding. Connected to the load. This is load. And the supply to this is given through the tappings. There are some tapping points. So this is actually a tap changer. You can connect either over here or here or here. There are some tappings. You can connect to, this is the input. This is the input. Actually this. So the following visual shows the tap changer of transformer. This is the transformer tappings. So the number of turns included in the circuit at one tap is different from the number of turns at another tap. The number of turns included in the circuit at one tap is different from the number of turns at another tap. That you can be set. For example, from one tap to another tap, you can vary the number of turns. Depends on your requirement. So that's why saying you that the number of turns included in the circuit at one tap is different from the number of turns at another tap. So the K is different at different taps. So the value of the K is also different at different tappings, and different voltages are obtained at different tappings. So the voltage mainly depends on the number of turns. So if the number of turns differ, the voltage also differs, and the value of K also differs. So that is why saying that the K is different at different tappings, and different voltages are obtained at different tappings. In continuation with tap changing, the tappings at which rated voltage is obtained at the output is known as principal tapping. Principal tapping. The tapping at which turns included are more than that of the principal tapping called positive tapping. And the tapping at which the turns are less than principal tapping is known as negative tapping. So the thing he's saying you that the tapping at which rated voltage is obtained at the output is known as principal tapping. That means at a particular tapping you will be obtaining some rated value, so that tapping is called principal tapping. And the tapping at which turns included or more than that of the principal tapping is called positive tapping. That means more than the rated voltage. The tapping at which the turns included more than that of the rated voltage or principal tapping, then that is called positive tapping. And if that is less than the principal tapping, then it is called negative tapping. So principal tapping is rated voltage, and positive tapping is beyond rated voltage, and negative tapping is below the rated voltage. So these are some technical terms in order to specify that that the tappings are principal. That means it is under rated voltage. And if it is called as a positive tapping, then it is to be understand that it is more than the rated voltage. And if it is negative tapping, then we need to understand that it is below the rated voltage. So this is the technical terminology used in the substations way to categorize. Tappings are provided on HV side windings. Generally the tappings are provided on the high voltage side winding. You can see here, this is HV side and this is LV side, as I've shown you in the previous. This is input AC supply. Number of tappings are 1, 2, 3, 4 and so on, you can see. And this is the secondary output. And you can also see that here off-load tap changing. So there are the tap settings over here and connected to the studs of the HV or primary. And this is input, this is primary input, this is secondary, this is offload tap changing, diagram of offload tap changing. So here you can see, as the number of turns on HV winding is large, a fine voltage regulation can be obtained. He's saying as the number of turns on HV winding, is large, so a fine voltage regulation can be obtained. The tap changing on HV side will be done at low currents. Why it is actually done the tappings on HV side only? Because in HV side the voltage is high but the current is low. So during tappings from one stud to the another stud or one tap to the another tap, when you just move the terminal, so during load you may be occur some sparks on change over the tappings. So that spark is due to huge currents. And if the currents are less, the sparking is less, and the currents are more, the sparking is more. If the sparking is more, there is a wear and tear problem and damage occurs and may burn also. It may lead to burn also. So in order to avoid that, if the value of current is low, the sparking is less and wear and tear problems are less and burn damage is also less, and there may be no damage. So in order to do that, we will be doing the tappings on HV side. Since HV side only has the low currents, LV side is having high currents in order to maintain the power constant. So tap changing on HV side will be done at low currents. And it is very difficult to tap LV winding as it is placed next to the core in view of insulation considerations. And also there is another technical aspect in order to do the tapping only on HV side is always the LV windings are placed next to the core, that means near to the core. So and HV winding are over the LV. Actually first there will be a core, and over the core there will be LV winding, and over the LV winding there will be HV winding. So the LV winding are inside the HV, so that will be mechanically some difficult to place the tappings. So it is very difficult to tap LV winding as it is placed next to the core in view of insulation considerations. So these are two main aspects in order to do only on HV. The tappings are done on only HV. And the HV winding is easily accessible and hence taps can be provided without any difficulty. The HV winding is easily accessible and hence taps can be provided without any difficulty. Moving on to the next slide. Offload tap changer. We have seen in the previous, that was the diagram was clear in the previous slide. Offload tap changer. there are some selector switches, and that is connected to the tappings. See, 1 2 3 4 5 and 6 with a selector switch that we can connect either to 1 2 3 4 5 or anything else, depends on your requirement. So this is an offload tap changer. So this is the following visual shows the offload tap changer, and it is very clear over here. In the previous slide it was not clear. You can see the clear offload tap changer diagram in this. The tap changing will be done by disconnecting the transformer from supply, and the name itself is saying you that offload tap changer. That means the load should be off. That means the transformer is isolated from the supply. So that is why the tap changing will be done by disconnecting the transformer from supply. And this is done so in order to avoid the sparks at the taps. By that, the damage, the wear and tear damage or burns may be avoided. The sparks are obtained only during the on-load tap changing. When there is no load or no supply on it, there won't be any spark since there is no supply in it. The problem arises only on on-load tap changing. So that is why the tap changing will be done by disconnecting the transformer from supply. The primary winding made into two parts and provided with tappings. You can see here the primary winding is made into two parts and provided with a multiple number of tappings equally on both. See, 1 2 3 on first part, 4 5 6 on the other part. The tappings are connected to respective terminals of selector switch, and all these tappings are connected to respective terminals of selector switch. This is a selector switch, and the number 1 is connected to the 1, 2 is to 2, 3 is to 3, 4 is to 4, 5 is to 5, all those things. The 1 2 3 4 5 6. This is 2, 3, 4, this is 4, and this is 5, and this is 6. So 1 is over here, 2 3 4, this is 5, and this is 6. So the tappings are connected to respective terminals of selector switch. The offload tap changer is shown in the figure, and the contactor will connect the different terminals of the winding tappings. The contactor will connect the different terminals of the winding tappings. So this is the information about offload tap changer. So this is diagram offload tap changer actually, but the visual is not present in this. That the diagram is in the previous slide only, in slide number 10. And in the continuation with offload tap changer, when third and fourth taps connected, you can see in the diagram that when 3 and 4 taps connected, all the turns in both parts of the windings are in use and provided 5% voltage regulation. and when 2 and 5 taps are connected, the rated voltage is obtained is known as principal tapping. As we have seen in the previous, if the rated voltage is obtained at that particular tapping, then that tapping is called principal tapping. When 1 and 6 taps are connected, the primary turns decreases and secondary voltage increases and provides plus 5% regulation. It provides plus 5% regulation. So we can see it again when 3 and 4 taps are connected and all the turns in both parts of the windings are used and provides minus 5% of voltage regulation, and when 2 and 5 taps are connected, then the rated voltage obtained and is known as principal tapping, and when 1 and 6 taps are connected, the primary turns decreases and secondary voltage increases. That means secondary turns increases, thereby secondary voltage increases, and thus provides positive 5% of regulation, plus 5% of regulation. And moving on to the next slide, there's a percentage voltage regulation at different tappings. You can see the taps 3, 4. That means when the taps 3, 4 are connected, 4, 2, 2, 5, 5, 1, and 1 and 6. You can see the percentage regulation for these taps. When the 3, 4 taps are connected, the regulation is minus 5%. That is percentage regulation is minus 5%. And when 4 and 2 taps are connected, then the percentage regulation is minus 2.5%. And when 2 and 5 taps are connected, then the percentage regulation is 0%. And when 5 and 1 taps are connected, then the percentage regulation is 2.5%. And when the taps 1 and 6 are connected, then the percentage regulation is 5%. So these are some percentage voltage regulations at different tappings. Moving on to the next slide. Now we'll see on-load tap changer. On-load tap changer. You can see the diagram. Of the transformer, that this is a conservator tank, and this is from main tank. This connection is from main tank, and this one is from tap changer, and this one is Bachel's relay for tap changer. We all know that actually Bachel's relay is used to detect the internal faults of the transformer. Virchow relay is used to detect the internal faults generated in the transformer. So this figure shows the on-load tap changer. Moving on to the next slide, the continuation of on-load tap changer. The basic principle that underlies all forms of tap changers designed to operate without opening the circuit. That means under continuity of supply. The essential feature is the small choke coil R, which prevents short circuiting a section of the main winding when the movable figures A and B are in contact with adjacent segments of the dial switch. And in this position, all turns of the main transformer are in service. So the basic principle that underlies all forms of tap changers designed to operate without opening the circuit. And the essential feature of the small choke coil R, which prevents the short circuiting a section of the main winding when the movable fingers A and B are in contact with adjacent segments of the dial switch. And in this position, all turns of the main transformer are in service. So in this, actually, previously there is an off-load tap changer and now it is an on-load tap changer. The difference is when the changing of the tap, there will be a spark produced in it if there is a supply in it, and if there is no supply, there is no issue of any spark, and if there is a supply, then only the issue of spark is involved. So that spark or short circuiting, see, the essential feature of a small choke coil or is inserted in order to prevent short circuiting a section of the main windings when the movable fingers A and B are in contact with adjacent segments of the dial switch. And moving on to the next slide, in continuation of on-load tap changer. Load current from tap 1 reaches point C by way of reactor coil R, and half of the current entering R by way of switch S1. The other half by way of switch S2, with the result that the MMFs of the two halves of R are in opposition, and the drop through R is insignificant because of its very small leakage reactance. He is saying us that load current from tap 1 reaches point C by way of reactor coil R, and half of the current entering R by way of switch S1. The other half by way of switch S2, with the result that the MMFs of the two halves of R are in opposition. And the drop through R is insignificant because of its very small leakage reactance. This is a diagram of on-load tap changer, but the picture is not. That this diagram will be same, but in on-load tap changer, that the supply is in the supply is in continuous. The procedure for this on-load tap changing is assume now that the voltage relay which activates the tap changing mechanism calls for a voltage less than that represented by tap 1. The contact figures A and B are rotated clockwise, but before A leaves stud 1, the switch S1 opens, thereby preventing arcing at the dial. So this is the kind of procedure involved in the continuation of the procedure in the next slide. When A establishes contact with stud 2, the switch S1 again closes. The reactor R is bridge across taps 1 and 2. The potential at point C of the reactor is then midway between the potentials of taps 1 and 2. If further reduction of voltage is necessary, the clockwise rotation of A and B continues, but just before B leaves stud 1, switch S2 is opened. And again is closed when B reaches to stud 2. And the reactor R is then again short circuited, and the potential of point C becomes same as that of tap 2. So these are some procedure points involved in the on-load tap changing. Now moving on to the summary, that what we have discussed in this class. So we have discussed about importance of tap changer, on-load tap changer, and off-load tap changer. So we have seen these 3 points as of now. What is the importance of tap changer, why it is done, and what is on-load tap changer and what is off-load tap changer. So let us move on to the small quiz. Tappings of a transformer are normally located on. Tappings of a transformer are normally located on HV side, LV side, HV or LV side, between LV and HV side. So tappings of a transformer are normally located on HV side, LV side, HV or LV side, between LV and HV side. As we have learnt in the previous cases that the tappings of a transformer are normally located on HV side, because in HV side we have low currents, that is one point, and the other is the LV winding is placed near to the core, next to the core, and the HV is placed over the LV. So that is why the tappings are very easy to done on HV side, and also the currents are less in order to avoid sparks in between the tappings. So that is why it is option A, HV side. Let us see it. So you can see it is HV side is the right answer. A, HV side is right. Going on to the next question. tap changer is used in a power transformer for tap changer is used in a power transformer for adjusting the primary voltage, adjusting the secondary voltage, adjusting both side voltages, adjusting the power factor. So the answer is we'll say the tap changer is used in a power transformer for adjusting the primary voltage, adjusting the secondary voltage, adjusting both side voltages, adjusting the power factor. So we can from the previous knowledge, actually the tap changer is used in the power transfer for HV side actually. So adjusting the primary voltage, adjusting the secondary voltage, actually it is connected to the load side means for distribution transformer or primary transformer that maybe on primary, adjusting the primary voltage, we'll see what is the right answer for it. Oh, it is adjusting the secondary voltage. Okay. Tap changer is used in a power transformer for adjusting the secondary voltage. Moving on to the next question. On-load tap change is done when the circuit is off condition, on condition, off or on condition, none of the above. On-load tap change is done on-load tap change is done when the circuit is actually on-load tap change is done when the circuit is in on condition only, obviously. So it is B, on condition. So we'll see the answer. The on-load tap changing is done when the circuit is on condition. So on-load tap change is done when the circuit is on condition. Go. And it's end of the session. We'll see some frequently asked questions in it. That is, describe the on-load tap changing with neat figure. Explain off-load tap changer with neat figure. And state the drawbacks of off-load tap changing. So that's it for the today's session. I hope you have got all the points. So it's end of the session. So thank you one and all. Have a nice day.